Alright, our first example is the integral of x squared plus 1 all cubed times 2x dx. So we want to integrate this. So what we're going to look at is we're going to focus on these problems on what to call u and then what we get du. So in this case I have quantity raised to a power, so this in here I can think of that as the inner part of my composite function. So I call this u. U is that inner part there. And then notice that when I find the differential of u du, it's 2x dx. So that takes care of the rest of that indefinite integral, the 2x dx. So I can rewrite this complicated integral as this much simpler integral here. So I haven't really changed anything. I've just rewritten it in a simpler way so that it's easier for me to understand what's going on there. And then I can do the antiderivative of u cubed. Du is real simple. It's u to the fourth over 4. So that's, could also write that as 1/4 u to the fourth plus c. And then I make this substitution back in now that I've done the antiderivative. And I get 1/4 times, instead of u to the fourth, I substitute that x squared plus 1 back in. 1/4 x squared plus 1 to the fourth plus c. So it would be a nice exercise for you now to pause the video and take the derivative of this and see what you get. You'll be able to verify that you actually get x squared plus 1 cubed times 2x as the derivative. Alright, next problem. We have the integral of x squared times the square root of x cubed plus 4 dx. Alright, so again, as I look at this function, I want to simplify it by letting some part of that function equal u, and we want to let the inner part of the composite function equal u. So this is a good candidate right here, this x cubed plus 4. So let's see what happens when we do that. When I let u equal x squared plus 4 and I take the differential of that, I get 3x squared. Alright, so I've taken care of this inner part here. I also have an x squared, which I now have taken care of, and the dx, which I've taken care of. But when I find this du, I get an extra 3 that I really don't want. So I'm going to rewrite this function as the square root of u du. But if I rewrote this way, this would be 3x squared times the square root of x cubed plus 4. And I really just want x squared times the square root of x cubed plus 4. So I have to offset this 3, this extra factor of 3 that I got when I took the differential of u, with a 1/3 here, so that this integral is equal to this integral, just rewritten. Once I do that, I have this in very simple form now with u to the 1/2. So again, that coefficient of 1/3 stays there. I add 1 to the exponent, divide by the new exponent. I have a plus c. Once I do the antiderivative, I can plug the x cubed plus 4 back in for u, and then I just have a little cleanup to do here. And I get 2/9 times x cubed plus 4 to the 3/2 power plus c. And again, if you pause the video and take the derivative of that, you will find that you do in fact get this this integrand here as your derivative when you take the derivative of that one. Alright, let's take a look at an example of a trig function. So here, remember, the cosine of 4x is like cosine of 4x is the argument of that cosine. It's the argument of that cosine function. So I'm going to let u equal the argument of the cosine. When I take the differential of that, I get 4 dx. Right, so I can rewrite this integral as integral of cosine of u du, but when I do that I get this extra 4. The du is not only the dx, but it's 4 dx. So I have to offset that with a 1/4 so that I don't change this integral at all. I'm just rewriting it in a different form. And then of course I can take the antiderivative of cosine of u. So I have 1/4 sine of u plus c, and then I can substitute that 4x back into the sine function, and I have 1/4 sine of 4x plus c. Again, if you take the derivative of this, you find that you get 1/4 cosine of 4x times 4. The 4 and the 1/4 cancel out, so we just have what we started out with as the integrand here. If we take the derivative of this, we should get cosine of 4x.